Okay, we're gonna go part 2. Example number 5. Let's do example number 5. We are on page 408. Simplify the expression. Okay, we're still continuing to simplify expressions here, okay? So note what they're asking. They're asking simplify the expression, okay? So I have cosine x over 1 minus sine x. And then I have minus sine x cosine x. Okay, so I'm trying to simplify this. So what would be the logical thing to do here? You could do that, but that would leave you with a rational function, one thing over another, and just a function, right? Which really doesn't give you a whole lot to work with at that point. So let's go ahead and try to combine the denominators, okay? Let's combine the denominators and see what that does for us, okay? So I have 1 minus sine x times cosine x. Over here, I'm going to multiply it like this. So I'm going to get cosine squared x. I'm going to multiply like this. I'm going to get minus sine x times 1 minus sine x. So I'm going to get 1 minus sine x on the bottom, cosine x. On the top, if I do this out, I get cosine squared x minus sine x plus sine squared x, correct? Because I have a negative times a negative here, becomes positive. And then ding, 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 I have a winner. Cosine squared x plus sine squared x, that is 1. So on the top, I get 1 minus sine x. Bottom, I had 1 minus sine x cosine x. So obviously the top, bottom cancel out. I end up with 1 over cosine x, which is, so all that mess turned into one simple secant x.
What a waste.
It's PFM. Okay?
What's PFM?
I
I think you're making stuff up.
It is PFM.
What does that mean?
What does that mean? PFM. It was an old Navy saying. Pure something magic.
Oh.
Okay, so. Example number 6. Example number 6, we're no longer simplifying. Read the question. It says find all values of x. So we're actually solving stuff now, okay? So example number 6, we are find all the where the cosine cubed x over sine x is equal to cotangent x. So cosine cubed x over sine x is equal to cotangent x. So this is cotangent x, and cotangent x is equal to what? Tangent x. So tangent x is equal to what then? So yeah, so this would be cosine over sine, right? Where tangent was sine over cosine. So it's the reciprocal of that. So this is actually cosine x over sine x. Correct? Okay, so what do we have? So if what can I do next? I can cross multiply. Yeah, what else can I do?
Multiply both sides by sine.
Yeah, can I just multiply both sides by sine x?
If you want, I guess.
right? So now realize when you're doing that, what are you assuming? You're assuming that sine x is not equal to 0, correct? Because if it's 0, you can't do that, right? Right? So just keep this in the back of your mind. Okay, we're assuming that. So we do that, we're going to end up with cosine cubed x is equal to cosine x. So you move this guy over here. It becomes that. Okay. So I'm going to get cosine x. If I pull one of the cosine x's out, I get cosine squared x minus 1 is equal to 0. Okay. So either cosine x can be 0. So cosine x can be equal to 0. Right? Or what else? Or cosine x can be equal to plus or minus 1, right? On this side? Am I given any restrictions there for?
Yeah.
Oh, x is between, by the way, x is between 0 and 2 pi. Okay, so at what point does these happen? Because any three of these can work for me. Yeah. When is cosine x equal to 0? When x is equal to?
Or wait.
What?
Pi over 2.
Oh,
What?
I don't know.
Pi over
Don't
2.
ask me.
Cosine x is equal to 1. Okay, let's do this one first. X equal to 0. Okay. So cosine x is the x or the y is the x. So when is it 0? And I'm up here, right? Or right? So pi over 2, basically, right?
And
Okay. So over here, when x is equal to cosine x is equal to 1 would be here, right?
what if it's minus 1?
So it'd be 0. Minus 1 would be over here, right? X value is now minus 1, right? Right? So we're going to be what?
Yep.
Oh, we'll go with that. Mr. On.
From here to here is pi, right? What?
It's different in the book.
It's different in the book. What's wrong with the book? Eh,
It's just the bottom one.
eh.
It's equal to
It's
0.
the same thing. It's the same thing.
Cosine is equal to 0.
It's the same thing, right? You get 0,
Is it just
0, and pi over 2, and 3 pi over 2. Where's the 3 pi over 2? What is negative 1?
bottom?
It's bottom.
It's also 0. Because we're only using cosine right now.
Yeah, we're only using cosine here.
So
So what the book did is that they changed this into negative sine squared x, right? And calling this 1 is this equal to 0. Same thing. You should get the same zeros, no matter what. Okay, so over here, cosine x is going to be equal to 0. So here, here, or here. So in the 0 point, what we missed was that I can be 0 at this or this. Correct?
Yeah.
What is cosine 3 pi over 2?
1, 0.
0. Exactly. What is cosine pi over 2?
0.
0.
So what's the x equals 0 and the x equals pi?
So this one here, so when it's 0, when it's 1, it's right here, right?
Yeah.
So that's 0. Okay, when it's,
Why are they using sine
Isn't
instead
that
of
one there?
is it what?
Why did they use sine in the book instead of
I don't know.
cosine x equals 1?
Okay, so this is the cosine where we're looking from 0 to 2 pi.
Yeah.
Okay, so we figured out what it's 0 is pi over 2 and 3 pi over 2, correct?
Yeah.
Okay, so here,
1 and then negative
okay, so it'd be 0, right? Or what's up here? This is 2 pi, right? Isn't this 2 pi? But 2 pi is not in our domain.
Nor is 0, right?
No, 0 is because it's this
okay.
bracket. Okay. We're almost done here. We're almost there. Okay, we're almost there. At -1, where am I here? Pi, right? So that's equal to pi, right?
Oh, okay. Seems like a lot to be fair. Why did they change it in the book to sine x equals 0?
Now, why does this not work?
Because sine pi does not equal 0.
Sine pi is 0,
What? Oh my gosh.
right?
Sine x.
Well, I guess that's why it doesn't work.
Oh, so we reject those possibilities because it equals 0, right?
Yep.
So why do we do that then?
Because sine pi is 0. I cannot multiply both sides by 0. That's one of the things that I assumed when I went here.
Why would we assume though?
Because otherwise,
Assume wrong, Mr. Ron.
no. This is why pi does not show up in the. What's the book answer? The book's answer is in what?
Us would be
I honestly
undefined.
don't know.
0.
I'm confused why they changed it to negative sign.
So it's pi into 3 pi over 2, correct?
3 pi over 2.
Yeah. So why does this not work? Why is this not there?
Because it equals 0.
Correct.
But
You
wouldn't
said
that
it
make
could
sense?
equal 0.
Yeah, you said it could equal 0.
I thought you said it couldn't equal 2 pi, but it could equal 0.
It's in the domain.
Yeah.
But sine 0 is 0.
It can be cosine.
Yeah, wouldn't it be 0
I can't have zeros on the bottom.
Oh.
then? Oh, okay, well, that makes sense.
So these two are no good
Yes.
because these two are they're in the zeros. It would make your denominator 0. Okay? A little complicated, but we got there.
Glad I came into
Only took like 20
Okay.
minutes.
All right? Okay, let's move on. Number 7. Hunter's brain is, I think has reached the full level.
All I know in this round is I'm glad I came.
Number 7.
I've been lost.
Number 7. Find all solutions to the trig equation that 2 sine squared x plus sine x is equal to 1. Okay, so what is this? If I move this one over here,
Equals 0.
okay, it's going to look like this, right? And now I have basically, don't I have a quadratic equation here?
Yes.
Yes.
Right, because if I put large x is equal to sine x, if I make that substitution in, I get 2x squared plus x minus 1 is equal to 0.
Why did they use y? Why not?
Because they're the book.
And now I'm all confused.
Okay, so I have 2x when I need to get a positive. So this needs to be positive, this needs to be negative. That's the factorization
2 and
of
negative
that.
1.
Equal to 0, which means that x, your large x, can be equal to either -1 or 1/2. Which means that really sine x can be -1 or 1/2, right? Because that's what our big X was, right? When is sine x equal to -1? Am I given another range or not? There is no range. So sine x is equal to -1 when? When does this happen? This is pi, this is 2 pi, 3 pi over 2, right? So x can be equal to 3 pi over 2, or it can be equal to 1/2. 1/2 is going to happen here and here. So that's going to be pi over 6, or 5 pi over 6. But then there are all the coterminal angles, right? I can go around 2 pi as many times as I want, right? 2n pi. Right, does that make sense? So that's the difference between this guy and the one before, is that they gave us a one circle between 0 and 2 pi. Right? Whereas this one, they did not give us that. So these are your answers. Right? Is that right? Yep, that's right. Okay. Okay. Not that hard, not that hard.
When you do it for many years.
Okay, the last one, example 8. Find all solutions to the equation cosine t is equal to 0.7.
No, it's calculator.
Oh, we're good.
Yeah, because you can't do this without it, right? I mean, does anybody know what 0.7 is? Is that like,
Yeah.
not like something that you're gonna memorize, right? So you just go ahead and graph it and then trace it and see where it hits the 0.7, correct? Pretty simple. All right, it's a wrap.
We want to do the
Wait,
whole
is it
thing.
number